Hey guys, we're on unit 4. So we're going to approximate with a tangent line and rates of change and things like that. It's called linearization. So in many instances, finding a y value of a function is difficult or impossible. With the use of calculus techniques, we can approximate the function's value by finding a y value on a tangent line to the function. Since this method involves using a linear function, the tangent line, at a nearby point, it's called local linearization. So look for that vocabulary when you are doing this. The approximation is actually coming from the slope. The slope is not the true slope, it's an approximation because we're using a coordinate that is close by to what we want. So example, if the point 2, -2 is a point on the graph, use the equation of a tangent line passing through the point 2, -2 to approximate. Now, the truth is though, we wouldn't actually need them to tell us 2, -2 because in A here, if we're looking at when x is 2.1 and we want to approximate, well, what's a number that's the closest to 2.1? Well, x is 2. And then when you're plugging in x, you can find y. They just happen to give us the coordinate in this example, but you don't need it. You actually could have said, hey, the best number to use that's close to this is 2, and then we'll plug all that in, okay? So when we're doing this, we're gonna make a tangent. We're gonna make a tangent line, okay? So that is our y minus y1 equals our slope times x minus x1, okay? So first of all, here's our x, here's our y. What do we need? We need our slope. How do we find slope? We find slope by finding the derivative. Now, if you look at this function, what you want to keep in mind is that since we have x's and y's on the same side, we're doing implicit differentiation. So that means any time that you take the derivative of a y, you're hooking on that y prime, okay? So do each part. So the derivative of x squared is 2x. The derivative of y squared is 2y, but we just took the derivative of a y, so we have to hook on a y prime. The derivative of 2y is 2. That was the derivative of a y, so we have to hook on that y prime, equals, and then the derivative of 4 is 0. Okay, again, we have to find the slope, but the way to do that is we want to solve for y prime here. So I'm going to move everything without a y prime onto the right side. So I get 2y y prime plus 2y prime equals -2x. We're going to factor out the y prime, so we just have one of them. So I get y prime times 2y plus 2 equals -2x. So y prime equals -2x over 2y plus 2. Okay? Now we are finding the slope at the coordinate 2, -2. A couple of things I want to keep in mind. Could we simplify this a little bit more? Yeah, we could get rid of the 2, right? Because they all have a 2 in there that we could do. Or keep it in there, plug it in. So right now what we're going to do is we're going to take our y prime and we're plugging in the coordinate 2, -2. Okay? And when we do that, when we plug in 2 for x and -2 for y, we get the value of 2. Okay, you can double check that on your calculator right now if you want. Now, there's our slope. So what we're going to do right now is we're going to make our tangent line. So we go y minus y1. Well, y1 is -2, so I'm going to change that to +2 equals our slope at that point, which was 2, times x minus x1, which is 2. So many 2's. This is our tangent line. We're going to use this tangent line to approximate where 2.1 is, right? So when I actually do all this, I can approximate. Now I'm going to move everything over here. So we get 2 times 2.1 minus 2. Now, by the way, I'm moving this over to minus 2. And now we can do all of that on our calculator, and it approximately is negative 1.8. And we're done. Okay, so approximation. Now, if instead it said use the coordinate, when the coordinate is x equals 1.9, well, what's the nearest whole number for that, which was 2? Well, we already did that up here, right? We found it when our coordinate was 2. So we're still going to use this, but now in our tangent line, instead of plugging in 2.1, we're going to plug in 1.9. And when we do that, we get the value negative 2.2. Okay, so approximation. This is not something we can do in our head. So what we're going to do is approximate it to the nearest whole number that allows us to get the tangent line and then plug in. All right. B, if f of 2 equals 3 and f prime of 2 is negative 2, use local linearization to approximate 2.01. Well, what do we have here, guys? We have an x, we have a y, and we have a slope. I know this because it said derivative. So really, I don't have to take any derivatives. I've already got it. I can go straight to the tangent line. The tangent line, okay, and I'll label it so we know what it is. Y minus y1, which is 3, equals our slope times x minus x1, which is 2. So this is our tangent line. So to approximate, we're going to put that number into our tangent line. So really, I'm saying y is approximately negative 2 times 2.01 minus 2. Now, of course, where'd that 3 go? I added it onto the other side here. And when we plug this into our calculator, or do a little math in our head if we have to, 2.98, and we are done. This process, where you need to keep in mind, is when it says linearization, or if we're approximating, okay? All right, and now let's look at some applications with rates of change. Now, one thing I want you to keep in mind is that this is a slope, rate of rainfall. Okay, this is time. So the graph at the right models the rate of rainfall in inches per hour from midnight to 6 a.m. So midnight 0, 6 a.m. is 6 during a tropical rainstorm. Write a complete sentence to explain the point A. The point A, of course, is at 3,1 on the graph. So we're including our units and explanation. This is a good thing for practicing those sentences. So what does this point mean? It means that because the x value is the time at 3 a.m., the rate of rainfall is 1 inch per hour. That's it. Okay. What is the slope of the graph between points A and B? Well, A and B, and what's our slope here? Our slope is 0. Write a complete sentence to explain the meaning of your answer to example 4. Okay, well, what does that mean? Well, between, because we always want to look at our units and what we're describing, between 3 a.m. and 4 a.m., the rate of rainfall, right? Because that's what we're talking about, rate of rainfall does not change. Or we could say that it's constant. Okay, we could say those two because we're describing what zero slope means. All right. What is the slope of the graph between points B and C? So if we look at this and we go, let's see, what is the slope? Alrighty. Well, it's negative, right? Now, here's the thing. Look at our y. Don't just count. We don't want to say 1, 2, 3, 4, 5 over 1. We don't want to say that. Look at our change. It goes from 1 to 0. So our change is 1. And then over, we're going over 1. So negative 1, right? Because it's a negative slope. Everybody see that? From B to C. The slope is negative 1. Now be careful of your units because this would be inches per hour, right? Because it's a rate over rate. All right, explain or write a complete sentence to explain the meaning of our example. So really focusing on these sentences. So let's look at our x. Our x represents time. So we're going to say between (4 a.m.) and 5 a.m., the rate of rainfall. Now, I'm not going to say negative. What does negative represent? It means decreasing. So the rate of rainfall decreases 1 inch per hour squared. Okay, this will take practice, and we'll talk about the x value, the y value, increasing, decreasing, and what it means to the situation. One of the biggest mistakes people will make on the AP test is they start using it, da, 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 da. No, describe what's going on. In this situation, we're talking about rainfall. So I'm going to keep saying rainfall. All right, let's do some practice.